we're going to look at a formal proof of a fairly simple result in number theory, which is that for all integers a, b, c, if a divides b or a divides c, then a divides the product bc. To begin, let's let a, b, and c be arbitrary integers. Okay? We want to prove two things. The first of which, since we are proving a disjunction, or an or statement, we want to prove if a divides b, then a divides bc. And also, if a divides c, then a divides bc. Okay? Now, in the first case, we are going to say, assume a divides b. Okay? This means there exists integer k such that b equals ka. Okay? Now, bc equals ka times c if we just substitute this expression from this previous equality. And if we use the commutative property and the associative property of multiplication, we can rewrite this as kc times a. Since, and maybe to be formal we can say since the integers are closed under multiplication, kc is an integer. Thus, a divides bc. Okay? And this is true since we've clearly here on the left started with bc, and then we got on the right some integer, which is kc, multiplied by a. Okay? And now, in the second case, it's really the same. So, assume that a divides c. So, let's say c equals na for integer n. Now, bc equals n na b. Okay, so bc equals nab. Since now we've replaced, and actually I'll write it in a way which shows what we've substituted. So we substituted c for na, and this equals bn times a. So a divides bc. And this concludes the proof.